think about that while I summarize. So, we have same curve, y equals 40 plus x squared over 3, from 0 to 12. And we think of dividing this up into a bunch of little trapezoids. And then this yellow trapezoid is going to be our typical trapezoid. And x star is going to be some x value in the corresponding interval. Well, that means x star is where? Well, somewhere between here and here, right? So, okay, here's x star. Now, that might be right in the middle, okay? But it might be to the left or right. It might correspond to an altitude, which would be from here up to here, that is equal to the average altitude. But it's not going to make much difference because the graph altitude on the left and the graph altitude on the right don't differ by very much, right? So whatever x star is, it's going to give us a pretty good estimate of our average altitude, isn't it? So, how do we get that? Well, we plug x star into this. Now this is a function of x, so we'll say y of x star equals 40 plus x star squared over 3. Okay? Now, assuming this as our representative radius, the solid of revolution.
Let's do the part that's exact first, shall we? Again, your choice. Raise your radius.
For this trapezoid.
All solutions or one rotation? Well, I'll tell you what. We'll do one rotation and then we'll go back and we'll do another thing at all. Okay. Here we go.
So what's the volume of this solid?
Which one am I talking about? Let's say that. Which one of these is on your inner circle? One. Tangent equals 1. Where?
Take this, rotate it around the x-axis. What do you have? Something very close to a disk with a certain radius and a certain thickness, right? That volume will be approximately pi times 40 plus x star squared over 3 squared, because this is going to be now the radius of that approximating disk, times delta x, where delta x is the width of the trapezoid, and I didn't label that, but that should be understood, right? Okay? So we can do that for any trapezoid, right? We could even very easily program a computer given an hour introduction into how to program in a simple language. Okay? We're not going to do that, but it'd be very easy to then just write a loop that calculates this for any number of sub-intervals. So I could tell the computer, well, calculate this, divide this interval from 0 to 12 up into 1,000 sub-intervals, each of length 0.012. Pick any point at random within each trapezoid and figure out the corresponding volume that you would have if you rotated that trapezoid, okay? Or that section of the graph, which isn't exactly trapezoid, okay? But very close, okay? And then add them up. You would have a result that gives you very nearly the correct volume, probably within 0.1%. If you subdivide it, probably better than that, 1,000 subdivisions. You have several significant figures that would agree with the exact value. Okay? So that could be done. And I say that simply to understand that, well, yeah, sum these up, and that would be very easy to do. Although if I asked you to calculate it by hand for 1,000 subintervals, you would be glad to go get an hour's instruction with a computer so you can avoid the months of calculation. Wouldn't be months, but it'd be weeks. Okay? You wouldn't be able to calculate it, but it wouldn't be hard to calculate it. It would just take a long time, right? So we know how to calculate this now.